morning, ladies and gentlemen. Myself, Ansari, the Director General of Wega Foods based in Cameroon. I'm a BTech graduate in sugar technology. I have 15 years of experience in the field of sugar industry with multiple domain of project design, operation of maintenance of raw sugar, plantation white sugar, and refined sugar. Thank you, Bharatiya Sugar and all members for giving me the opportunity to share my experience on sugar refinery operation risk management with incredible efficiency and outcomes, which will be discussed further in details. I would like to introduce about my company. Wega Food is owned by Mr. Vekwi Ngandu, who has a multiple business like sugar refinery, salt refinery, 4-star hotels, Gamma Energy, Gamma Logistics, wine factory, and multiple land businesses. Wega Food is the only standalone refinery located in Cameroon. The civil construction was started after post-COVID in November 21 with a lot of challenges because of seashore and 8-month rainfall. The equipment was started to supply from Shriji Group in June 21 from India and completed in July 22 with complications of custom clearance and high variation in sea freights. The installation was completed by March 24 and led to the cold commissioning with effective production since 20th of April 2024. Being as a standalone refinery, natural gas was the only prime source for running the boiler. Since April 24 to October 24, it was a tough time for Wega Food because there was a natural gas shortage in the country. After detailed analysis and reviews, we came to a conclusion that we have to look for a dual fuel, and we have shifted to LPG with some modifications in the existing boiler and adding the LPG equipments. We faced new challenges while putting the project of LPG, as it was totally not part of the design, but we implemented it, and initially there was a supplier's problems also. By the start of 25th, since January, we were in a full-fledged operations, and from January to April 25, as the factory was shut and stop, and the reason the boiler was having a high thermal shock, and we were forced to do the tube expanding again. This is introduction of our plant, Wega Food, having our address. The installed capacity of the plant is 300 TPD standalone refinery. The plant was supplied and installed by Shriji Process Engineering Works Limited, India. The board of directors are Vekwi Ngandu Mark, Vekwi Ngandu Christian, Vekwi Mark, Vekwi Polavadaris, who is here around. Today's topic is about the risk management, what we have to look after for efficient working of the factory. The risks are mainly defined into two parts, that is a positive risk and a negative risk. Positive risk, a leader should always look around. Positive risk is an opportunity. It has a smooth and consistent operations with a high efficiency, reduce in the time and cost. It has an improved performance over the factory, which increase the market share and enhance the reputation of the organization, making it more profitable. The example is running the factory to optimum capacity or reduction in OPEX. OPEX is a vital role for recovery of the factory. Negative risk is a threat. It can have a technical failure, and because of technical failures and other failures, it has a delay and cost overruns. It has a low performance, shortfall, or losses on the reputations of the company also. Or in case of start and stop and other cases, your reputations are lost and you have lost the clients. For example, running the factory under capacity or procurement of substandard materials like chemicals, spares, or moving to one direction that the factory is designed for NG, and we are not going to adopt a new technology or new source of gas, then you are going on a negative risk, and that makes you a downfall. Risk can be further break down into technical risk, internal risk, external risk, managemental risk, or commercial risk, which can be further break down in subdivisions. Risk is mainly classified into 6 standards: known, 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 unknown, unknown, known, 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 unknown, unknown, effect-based, and source-based. When we talk about known, known, information that is fully studied and understood by the person who is operating the system. For example, a raw melt bricks is on the lower side. An operator needs to adjust the sweet water with respect to the raw sugar input. For example, when we talk about known unknown, the information that is understood to the operator, but he is not capable to resolve it from his own part. For example, a melt concentrator vacuum is dropping, other colleague assistance is needed. For example, there is a leakages, a gland leakages, or equalization leakages. You have to call your mechanical team, or if there is a if there is an instrument failure, you have to call your instrument team to attend it. So operator knows the risk, operator is aware about it, but he don't know how to resolve it by himself. When we talk about unknown known, information that an individual organization has in its possession, but whose existence, relevance, value has not been really realized. For example, there is a huge losses in the sugar, but in the gutter, but the people thinks, no, it is a minor. But as per my analysis, we have to identify the leakages and arrest in all the loopholes, which has a high impact of economy for the organization. Unknown loss is something like unforeseeable. You cannot see, you cannot realize, but the existence is there. For example, a sugar trace is observed in the boiler water, or a pH or conductivity is increased because of improper operating of the demineralization plant, or whatsoever, or a poor workmanship. For that cases, we need to go for a root cause analysis, which will be discussed further, and we have to find a proper corrective action and a planning on it. The risk is also based on effect-based information that can be related to the source, schedule, cost, and quality. For example, an IR color is increasing. We need to check whether the regeneration is done on time or not, acid washing cycle has been counted on time or not. Higher the color, lower the outcome, increase the losses to maintain the same quality, or either of the way, or vice versa. If you want to subgrade the quality, then to maintain the losses, then you have to degrade the quality. So that is why it is related to the source, quality, and cost. Source-based risk is coming from the different source information that can be internal or external, technical, non-technical, or generic. For example, a foreign material is coming in the raw sugar. We have to alert to the supplier to provide the proper inputs. Or on the plan B, we have to check that we have proper magnet, grid plates, screening to avoid all those kind of things. Or if the chemical purity is below, we are degrading by ourselves and falling our economy. For example, a CO of a lime is below, suppose 680, then we ourselves are the one who is responsible to take that chemical into our account, which is a source-based. How to handle the risk? The risk can be handled in 5 different stages. That is, first of all, you have to identify, analyze, you have to check the risk impact, you have to check the risk response strategies, and the risk has to be monitored. To identify the risk, there are plenty of analysis which can be done. Risk, which will be discussed further. Risk identification techniques in sugar plant. The risk identification techniques are divided into 5 different parts. That is, in general, what we do, what to be done by the production team, what is to be done by the laboratory team, what is to be done by the mechanical team, what is to be done by the electrical or instrument team. Most of the things are done, but not documented well. If it is not documented, you cannot have a proper future planning program. In general, we discuss about SOP for the equipment, operation and manuals, logbook records at each workstation, office and workstation trainings, Explanation on troubleshooting at the floor plan, daily stand-up meeting, weekly review meeting, tools and tackle shift-wise inventory stock checks, store inwards and outward checks, firefighting equipment weekly operation checks, lesson run records, shutdown records. Production, we are going for a routine checks and cleaning of raw sugar handling equipments, routine checks and cleaning of clarification equipments, DBF and IER best operation practices based on production and lab analysis. Water boiling best operation practices for heat transfer equipment. For example, for a pan, after 20 cycles of a pan, you should go for a water boiling. You have to find a way with different Monte Carlo analysis or decision tree analysis that after 20, 22, 25, which is the best operation, best practice when the pan has to be done a water boiling. Routine check and cleaning of centrifugal machines and refined sugar handling equipment to run consistent. That's a part of positive risk. Weekly chemical filters, bag, consumable stock records. When you are working in an international market, you cannot get easily this kind of materials in your stock. WTP best operation practices when you are located in a seashore and you are having an RO plant, which is the prime source of using the water for running the refinery. Laboratory, apart from the regular analysis like pole, breaks, purity and other things, we have to do for a special analysis of raw sugar, refined sugar, to know each and every part of the raw sugar and refined sugar, which is going to impact on your production and efficiency of the factory. Special analysis of the chemical receipt. If you are not making a special analysis of chemical receipt and you are buying the same chemical on the same price, means you are losing your economy. Special analysis of boiler water with aquascan equipments, what is easily available in the market. Best operation practices for condensate water at each point, especially after turbine restart. Best operation practices for loss of water and water channel and gutters. Mechanical, we should always look for a preventive maintenance schedule records that has to be done in a daily basis, weekly basis, monthly basis, quarterly basis, so that we should know what we are taking in and what we are taking out, and the equipments are maintained well. Boiler operation reports review on daily basis, turbine operation review reports on daily basis, oil top-up check sheets, each rotating equipment running hour records to ensure that the equipments are not going into an accidental failures. Shift-wide troubleshooting records to analyze which shift is performing well. When we talk about electrical and instrumentation, we should have a checklist of MCC and VFD panels. We should have MCC, VFD, and PCC. Each breaker setting checks, earthing monitoring reports, critical parameter checks. For example, all the bricks transmitters, conductivity transmitters, all the transmitters which are related to the refinery has to be routinely checked on daily basis. Compressors, working hours, diesel generator working hours in case of accidental turbine trips, you should have a backup plan when you are working with a refinery for a high purity material. Field instrumentation check and air conditioners operation records. Moving forward to the risk analysis techniques. Risk analysis techniques are done in a major three parts: qualitative analysis, quantitative analysis, and other risk analysis to be accounted when you are going for the risk analysis techniques. Qualitative and risk analysis techniques is mainly related to the production, time, cost, and quality. It is identified by the probability and impact matrix based on the risk subdivision as very low, low, moderate, high, or very high. For example, bagging a fine grain of 150 micron plus, which will increase the production, reduce in recirculation and the steam demand, which will also have a better quality sugar result in the finished product. Quantitative risk analysis is mainly related to the figure. It is a process of numerical analyzing the combined effect of identified individual production risk and other sources of uncertainty on overall production objectives. Techniques that are used to do the quantitative analysis is simulation techniques, Monte Carlo analysis, which is automatically generated by AI tools, decision tree analysis, sensitivity analysis, influence diagram. I always like to work on decision tree analysis. I can give an example of an cam water. Suppose a cam water is costing you per day in $150, but you are increasing a production of 10 tons per day. Overall, you are increasing a monthly production of 300 tons, and you are spending just $4,500, which is easily recoverable. So people think that we are investing on a higher side, but we are not recovering much better. So we should always do a decision tree analysis whenever we have to move forward. Other risk analysis to be accounted like a business risk and the secondary risk. Business risk is like a procuring a raw sugar on an annual demand. It can have a price, currency variation, logistic markets, market demands and sales, force majeure conditions, money blockage, etc. This risk has to be accounted when you are going for an annual contract. Secondary risk. When you are taking a first action on the first risk, you should always remember what is the consequences. For example, we are thinking that the scum from the third stage can overflow if the pump is failed to pump to the filter press. And in that case, you put the overflow into the scum first stage, scum receiving tank, you are circulating the scum and damaging the system. So that is the secondary risk one should always encounter when you are taking a first risk on, action on the first risk. Risk response strategies are divided into two parts, that is positive response strategies and negative response strategies, which are further subdivided into 5 different types: escalate, exploit, share, enhance, and accept in a positive response strategies. Escalate, avoid, transfer, mitigate, and accept in a negative response strategies. When we talk about escalate of a positive response strategies, purchasing of raw sugar based on the factory demand and a situation when the prices are decreasing. For example, the prices of the dollar is decreasing and the prices of the euro is increasing. So we are buying in a dollar or euro, or the Cameroon is governed by the euro. So this is the right time to purchase the sugar. So we should always take an advantage of the time and the situations. So that's a positive response strategy. And when you go for a negative response strategy, for the escalate one, you are having a fixed contract despite of the price violation, despite of the currency variation, despite of the force majeure condition, despite of the market values. Exploit, coming back to the positive response strategy, running the factory with NG and LPG for a higher economy and a dual option. Avoid, running the factory on a single source of natural gas as a fuel based on the design of the factory is making you a failure. Share, taking a maintenance services of any rotating equipment like a turbine and centrifugal machine. So you are sharing the risk between you and the service party. But when you want to transfer, just like you are taking an annual contract of a rotating equipment like a turbine and spending a huge money like an insurance to the company. Enhance, avoid the fine grain recirculations over 150 micron from the sizer to Rory melter. It will increase the production, which will have a color advantage and reduce the stream demand. Some risk you cannot cut off, so you just need to mitigate it. You can just reduce it, providing a scalping screen for a rotary sugar dryer to cut the load of the elevator and sizer grating. Accept, if the risk is considered as an opportunity with respect to the risk response of exploit, share, and enhance, it should be accepted. If the risk is known, but the impact has a minimum impact, minimum impact on the operation, then it should be accepted and converted with a known risk. Contingency response, a fallback plan. A leader should always have a fallback plan when he is working on a risk management strategy. He should not have a single plan and put his company on a stake that we are going on the one plan. If suppose that fails, immediately without wasting the time, you should work on the fallback. You should activate your plan B as a fallback plan. Major risk analysis case studies, which has been done on Wega foods, like a boiler flue gas. Switching to LPG with some modification, we got a higher plant stability, higher the productivity, high factory efficiency, we have a cost economy, we have an alternate source. We are not stopping the factory since January to till date, as we are working in a dual source of fuel, and the factory is running with a very economical mode, which will be shared in the graph. Steam saving equipment. There are certain things like resource handling and resource leveling. We are working on the resource smoothing because we cannot level the resource at this stage. We have to see what is the available resource, as we have just commissioned the company, we have just commissioned the plant and running with the available resource. So we are adding to the steam saving equipment like a DCH and a new melt concentrator with the help of Rahi Techno Services. Injection of exhaust to melter, injection of exhaust to melt concentrator. These are related to the resource smoothing. As I don't have a DCH to recirculate the melt, so I have to inject the melter and increase the production. When I have injected the melter, the plant capacity has increased from its 60% to directly 80%. It has a consistency in a steam feed. The reason melting was consistent and effective with effective melt bricks, which give an advantage over production, rise an indirect impact to the better steam consumption with available resource. To mitigate the risk over melt passing to the turbine, additional NRVs were provided to all checkpoints. In future, we'll adapt to DCH and all these things will be discarded. Injection of exhaust to the melt concentrator. Again, it has a constant steam feed. The reason bleeding was effective and constant rise in the melt bricks was achieved, and the production was increased to 120% of the available capacity utilization with the available resource. In future, we have added a new melt concentrator to overcome this risk. Water consumption. When you are working in a standalone refinery, water plays a vital role. So with the RO efficiency, we have done a rainwater harvestment to reduce the load of the RO, and we have achieved a better results, and the RO life has been increased. We have also injected a caustic soda dosing at the RO2 to cut off the load of the MB, and the MB time has increased, and the MB regeneration is coming now after 4 running days based on the boiler requirement. Implemented best operation practices for pan boiling. With that, we have a higher productivity with less losses and enhance the we have also enhanced the recovery side crystallizer capacity for better exhaustion of molasses. Sugar handling equipment breakdowns. In the startup of commissioning, we were having too much breakdowns in the sugar handling equipments. We implemented automation interlocks, and without interlocks, operator don't have a power to restart the equipment without setting it to automation. We have put additional rubber lining on the top drum. We have put the external bearings to the bottom side to overcome the frequent stoppage. Control over electrical trips on turbine. When we are having a small refinery, there are a lot of complications which we cannot do, which we cannot move forward, as like we cannot have ACB for such a small refinery. So we have a MCCB. To avoid a trip on the turbine, for the single phase, we provided RCCBO for individual maintenance at each workstation. And in case there is a short circuit or any case, the RCCBO is stripped rather than MCC and turbine is stripped. We have changed the neutral earth pit location. Based on the seashore, we realized that the groundwater is coming even at 1.5 meter when you dig. So we increased the length of the neutral earth pit of ACB and found better results. Control over batch machine trippings. Again, based on the available resource, it was a DC drive provided by the supplier. So we have reduced the cycle time to get a frequent damage of fuses and thyristor. We are also informing the boiler and turbine team to give a wake-up call to the process supervisor to shut down the machine in case of any accidental failures at the boiler or turbine sides, if it is possible. Control over trippings of PLC. We have provided additional TB on the field side so that the TB is tripped rather than PLC is getting frequently tipped and the card was getting damaged. So this has given a better result to us. Chemical, consumable, and spare part inventory management. We have started to trace the local suppliers who can give a best chemicals, consumables with the shortest time delivery rather than looking for a custom payment, transit time, hazardous materials, and the factories hold for it. Deputation and training on local manpower. At present, we are running the refinery with 96% of the local manpower. Only the governing peoples are the Indians, else all are the local manpowers, including the boiler, turbine, and batch or continuous centrifugal machine operators. Language and work culture semantics. When we started the refinery, the major challenges was this only. There was a language barrier between the French and English. There was a semantic barrier. To overcome that barrier, risk management has helped me a lot with proper checklist implementation on station by station and getting the reports. When you have a checklist, you don't need to talk, just need to get verified that it is attended or not attended, and makes the things much better and efficient. I would like to share the performance graph, shipment-wise performance graph. At present, we are running the fourth shipment of 23,000 ton. When you see the startup, the bagging, the melting was very low, and the recovery was 89. On the second shipment, the recovery was 95.33. On the third shipment, we have reached to the extreme level, and the recovery was 97.71%. On the present shipment, the estimated recovery is 97.32%. The total shutdown, as I stated earlier, from January to April, it was a forced shutdown, and the shutdown for the factory was 31.89%. On the second shipment, it was 29%. On the third shipment, it is 13.2%. And the present shipment, the shutdown is just 0.52%. Factory efficiency at the start was,
Ansari, sir.
During the commissioning, it was 68. Later, it has come to 71. In the third shipment, it was 86.73. On the fourth shipment, now it is 99.48. That's a great achievement from us. When we talk about the losses was 10.49% because we are not running the scum desweetening equipment followed by filter press. On the second shipment, it was 4.40%. On the third shipment, it was 2.29%, and the fourth shipment, the estimated is 2.5%.
Sir, conclude. Time is over.
Chari slide over. When we are talking about the losses has been decreased as stated here. The final molasses losses has come from 3% to 0.73% presently. The filter case losses has come to 0.02%. The unknown losses has come to 1.24. This is the quarterly performance graph of our factory. The important part here is factory capacity utilization on effective running hours is from April it is 98.63%, in May it is 105.74%, in June it is 118.38%, and the losses has already come down. This is the plant economy graph. The steam consumption was 2.19% during the commissioning, which came to 1.298, and at present it is 1.03%. With the available resource, in further we are working on the steam saving equipment, which will even come down below 1. The power was 119 during the commissioning, and at present it is 62 kilowatt per ton of raw sugar. Gas consumption was 114, and at present it is 65.44% per ton of raw sugar. This is a comparative of between the raw sugar and the blended refined sugar. The moisture reducing sugar, especially I will talk about the pole. The pole of raw sugar was 98.9%. 98.9%. The refined sugar is 99.7. The color is below 1000. The target, and we are receiving 969. And
Sir, conclude.
our color has received at below 41%, below 41 IU. Thank you. Thank you for listening on my topic. I am looking forward to take your questions in case you have.
Congratulations, Mr. Ansari. It is a very good paper. You have given the account right from the inception of your factory to date, and how you have developed from the negative to positive.
Exactly.
Actually, I feel this is the lesson what to do and what not to do for the new establishment who is going to put up a new plant. They must learn from this paper what not to do. That is very important. So we have gone many times to success stories. This is actually a failure to success. Right, Mr. Ansari?
Yes, sir.
So this is very good. I congratulate you.
Thank you, sir. And I will take your 3 minutes time to show our video.
सारे जहां की शान है, हम सबका है अभिमान। इस धरती को दे खुशहाली, शान अपनी किसान। आओ मिलके साथ चले हम कामयाबी की डगर, नाम एक ही इस दुनिया का, भारतीय शुगर, भारतीय शुगर, भारतीय शुगर अवार्ड, भारतीय शुगर, भारतीय शुगर, भारतीय शुगर, भारतीय शुगर अवार्ड, भारतीय शुगर। सारे जहां की शान है, हम सबका है अभिमान। इस धरती को दे खुशहाली, शान अपनी किसान। आओ मिलके साथ चले हम कामयाबी की डगर, नाम एक ही इस दुनिया का, भारतीय शुगर, भारतीय शुगर, भारतीय शुगर अवार्ड, भारतीय शुगर, भारतीय शुगर, भारतीय शुगर, भारतीय शुगर अवार्ड, भारतीय शुगर।
Hello. My one question about water management, stated water management. At Kandla refinery, we are going to water management. We install multi-effect evaporator, plate type evaporator to concentrate the spent was up to 45 degrees, then followed by ETFD to solidify this. And condensate we have treated in RDRO and then reuse to reduce the effluent load on ETP, to reduce the river water load. It is essential to each every sugar factory. It is very important, also sugar plant, also refinery plant also. To avoid the load on ETP, we want to replace ETP by this technology.
Sir, I have noted your point. At present, I am working on resource leveling and resource smoothing. So just now we have started the refinery before not even one year. So in future, we are planning to go for surface condenser to cut off all the loads. Thank you.
Sir, question to you, sir. E-gasification, is it similar to